Yeah, so hey, we're here to talk about our Stargate API from DataStax. It's a complete open source layer that sits on top of your data and can expose it in a variety of ways that your that your developers can use. So all right, let's see if the clicker works, huh? Oh, I wonder if I have to like click over to that. Maybe if it has focus, it'll work. Needs focus. Okay, so hey, also in case you hadn't noticed here, by coming in person, you have a chance to win a $500 gift card sponsored by Home Depot. So I think just two of you here, your odds are looking pretty good, right? Anyway, so hey, I don't spend a whole lot of time on me, but I'm a developer advocate for DataStax. I spent a lot of time on Stack Overflow and the Cassandra tag. I've written a couple of books on Cassandra and NoSQL databases. And I was also the NoSQL engineering lead at Target for about 5 years. So, I spent a lot of time, building out like large scale, high performing database systems. So, Cassandra was always my wheelhouse. I've been working on Cassandra for about a decade now. This is, that's it. So materials for today, really the only thing you're going to need is this link will get you to our GitHub repo that has a README that basically walks you through all the steps that I'm going to show you. The only other thing, and the README talks about this too, is setting up a database as a service in the background. It's a part of our free plan, so you won't have to worry about anything from like a cost aspect there. All right, so here's our agenda. We're going to talk a little bit about okay, data API. Why would you want one? And then a little bit about the main access methods of like REST and GraphQL and gRPC. A little about the data gateway itself, and then Stargate, and then we'll go right to the demo and hopefully cruise through this in the next what do we got left here? 45 minutes, something like that. All right. So with a why, my manager Cedric actually put this together. He's given this one before, but he has some really good questions here. Like, as a developer, do you want to have to learn a whole bunch of DSLs or domain-specific languages? A bunch of different ways to get your data or talk to databases, and the answer is you probably don't. Do you care about how your data is stored? Well, if you look at a lot of bigger companies, they're really working hard to abstract that away. So, the developers will go ahead and really not have much idea of what's going on in the back end, but it's your database engineering folks who are really kind of taking care of that and providing it in the right way. And of course, that last one for development, do you really like installing and running a whole bunch of databases locally? In my case, I'm a bit of a database nerd. I probably have, 12 different databases on my laptop I could spin up right now, and like 4 of them are different versions of Cassandra, but that's okay. The point is that if you're a dev, though, you really don't want to have to think about that stuff. So of course, for operators and DBAs too, it's like, do you really want developers to execute queries directly on the database? You probably don't. Do you want to have to worry about opening, like a whole bunch of ports to give access? It starts getting into the security aspect of it, and really how open do we want to make things? How vulnerable are we when we do that? And then of course, do you like creating dedicated projects and hiring people just to do this stuff and just to manage all of that infra? And it's probably not something that's terribly cost effective. All right, so of course, most developers are familiar with REST. Especially if you're using something like OpenAPI, where you can like easily spin up a Swagger spec like this. But REST is pretty simple. It's just your basic get, post, put, deletes as well, patch if you will. Oh, there we go. Oh, did I skip one? No, okay. So yeah, gRPC. A little more complicated. It's the remote procedure call from Google. Very, very high performing. Does tend to be a little more tightly coupled though, but it is one of the things that we do offer through Stargate if you want to connect over using gRPC. GraphQL, of course, is really getting a lot of attention lately. In terms of just the simplicity of being able to abstract a lot of different data sources, being able to pull back exactly what you want. Very, very, very simple. Oh yeah, I already mentioned those points. So yeah, GraphQL, haha. You'll find in the workshop part that I'm not really that great with GraphQL yet. I'm still learning it myself. But anyway, I just thought I'd throw that out there for when I hose something up during the GraphQL portion. So anyway, you start looking at a lot of the criteria of how you'd think about how you choose things, how different people choose things like your data models and your database family, et cetera, et cetera. A lot of the different decision points, and it can all get very, very confusing quickly. And yes, you can tell that that Cedric, my manager, put this one together because it's written in French. But anyway, I digress. So you could do his point is you could do like a matrix analysis and get really detailed with a lot of these decision points. And it would lead you to this great decision tree, which of course is very, very simple, right? I mean, nobody wants to do this. So there are some simple points. You can look at each method of connecting, and you can ascertain its pros and cons, and maybe just some generals about it. REST is very good at decoupling. It's very good at like life cycling or versioning. Tooling is very abundant out there as well. Drawbacks of REST. Well, you have some verbose payloads. And again, unless you're using like OpenAPI and building a Swagger spec, it doesn't really have that automatic discoverability. It's kind of something you have to think about when you're architecting that out. It's great for like CRUD, create, read, update, delete type of operations. Like running a command structure through it, probably not so great. And it also sees a lot of use through like public and web APIs. Really good for OLTP. Now, if we move on to gRPC, as I mentioned, it's a little more high performing. It'll allow you to do things either synchronous or asynchronous, or streaming actually too, and multiple languages, of course. The drawback of gRPC, like I said, it's a little more strongly coupled. You have your proto files that that you have locally when you connect it. You kind of have to know what that underlying schema is. And if you change it, you have to make sure you change your proto file as well. So that can be a little tricky, but you want to make sure you're just considering those things. But really, it's great for command-like structures or places where you need like high amounts of throughput and performance. So that's gRPC. And then of course GraphQL. It's easily discoverable. You can have your custom payloads. It matches standards well. Kind of some of the drawbacks is at the implementation level, as far as like the database engineering side, that can be a little complex, so it's great in that it abstracts everything away and makes it easy for your developers to use. But, for your database folks, it can be pretty complex to get set up and get everything exposed. But yeah, GraphQL overall, it's known as the back end for the front end. It's one of those that you could call straight from a, JavaScript, web-based app if you had to. It's good for when volume matters because again, you can like customize your payloads. You want to keep things kind of low when you're working on like mobile in the mobile paradigm, for example. All right. So our data gateway, the one that we use is we've called it Stargate. See, there you go. That's the point here. I wonder if these slides should be in the opposite order. But anyway, so you have your developers that go through Stargate, and that sits on top of Cassandra, AstroDB, and really, you can extend it out to a custom data source if you like to. Now if I go back to this one, you can see that Stargate offers things like gRPC, REST. You can work with JSON, OpenAPI, GraphQL. So anyway, yeah, it makes working with a data source to the point where you don't really need to care what that data source looks like, which is really, really cool.
And Aaron, what's the difference between then a data mesh in this Stargate.
Ooh.
So how does it make it?
Yeah. So I think wow, I'm not too familiar with data mesh, but my impression of it is that that involves, a data mesh is more like analytical, more like OLAP type processing. Where you'd have like your sources for doing analytics, but maybe building out like a graph, type of a structure.
Okay, in my head, I always envisioned data mesh to be more of giving an outside-in view for the data sets.
Oh.
So that's, at least in my head, that's
okay. Okay.
I could be wrong.
Yeah. I have to be honest. I don't know.
Okay. And how about using async APIs? Does Stargate support async?
Yes.
Okay.
Yes. Especially through gRPC can that allows for that as well. With the other ones, if you're doing like a REST-based call, that would be probably more language dependent, from where you're calling that. But yeah, you can do async absolutely.
Okay. And how do we manage the async calls along with the contracts? So that's where it becomes tricky when you talk about true event sourcing. I don't even want to go towards event driven. I'm talking about more on event sourcing kind of.
Oh, okay. Yeah, that would be kind of tricky. You're thinking about like in terms of like the order that they come back in.
Yes.
Yeah. I don't know if there's a way to guarantee that, to be honest. I mean, certainly, you could do something, thinking from a Java paradigm where you had like a group of asynchronous threads, and let's say that you kick those off, and once you're like the number of threads that you want to limit in flight is done, you can go iterate through and then like listen for them to all complete. But again, yeah, like the order that they would complete in, yeah, I don't know that can be. That's a good question. Yeah, I don't know that could be enforced. Yeah. Oh, I'm going to be thinking about that one now. All right. So Stargate, of course, is our open source data gateway. Yeah, what do we got next here? Oh, yeah, okay. So this is the cool part, where we kind of show, really what Stargate does. So we have our API extensions, and we've talked about those quite a bit, and then of course our persistence options underneath, and then Stargate, of course, takes care of that security piece as well. So we have with Stargate, it'll work through REST, GraphQL. We have a document API as well. So if you're used to working with things like Mongo, for instance, Elasticsearch to some extent, but it'll work with things in like a document type structure where it doesn't enforce any type of schema or anything like that. You can use CQL if you love using CQL in Cassandra. I would choose that option, to be honest, because I'm a bit of a Cassandra nerd, but that's okay. And then of course gRPC we've talked a whole lot about. Hey there, Theo, how's it going? All right. And then on the persistent side, we can have Stargate talk to multiple versions of Cassandra, DataStax Enterprise, of course, which is really just an enterprise grade version of Cassandra itself. And AsterDB, which is a Cassandra as a service. Hey, there we go. Okay. So a little bit about Cassandra. I don't know how familiar folks are in the audience overall, but it's a NoSQL database. It's distributed, which is kind of the key, and it's also what's known as like an AP database. So it's highly available and partition tolerant. And the idea with Cassandra is that the infra underneath works on like a node structure, and it's peer-to-peer communication. So there's no one single point of failure. So we have like one node out there, and maybe we have a whole bunch of nodes out there. One of the things that I've set up too in the past at one of my last jobs is like out in the cloud we'll have like maybe even like 100 nodes out in like Google East, and then maybe another 100 out in Google Central. And that way we're able to serve like different, geographically diverse customer groups, with a little more data locality for them. So that's kind of the idea behind it. And the cool thing is that these nodes, they do something called a gossip, so there's no single point of failure. It's, Yeah, peer-to-peer. Oh, yeah, data center ring. So the idea is that data distribution with Cassandra it all works on like a hash of the primary key, or the partition key in this case. And you can see the partition key is like the country code. So essentially that gets hashed, and then each node has like a range of partition tokens that it's responsible for. So what this looks like is those all get hashed, and that's how it figures out, which node is responsible for which data. Of course, your replication factor also plays into that a little bit too. So if you have like a replication factor of 3, it'll do like a neighboring node computation to also store Sydney and Mumbai, on this node over here and in this one there as well. And that's just so that you can, in case one node goes away, you're not missing a relevant subset of your data. So, all right. And again, the other cool thing with Cassandra is its data is distributed everywhere. I talked a little bit about having, those, resilient, highly available deployments in like, Google Central, Google East, but really that works for around the world. I mean, we have customers who serve, their own customers in Europe, in Asia Pacific, in the US, and they do this all simultaneously with data that's got to be written and then replicated basically everywhere. So that's what Cassandra does really, really well. Okay, there's a lot that goes into understanding use cases that you'd build out on a distributed database like Cassandra. It works into scalability. How big do you need to make the cluster to support things like heavy reads, heavy writes, and that comes out to like things that are like IoT, time series. Under the hood, Cassandra works with a log structured merge tree. So really anything that's like event-based, time-based, log-based is going to work very, very well in terms of that, that underlying data structure. I've talked a lot about availability too. Again, it's for mission critical workloads. You've got essentially the infra underneath that if you lose something, it's not going to make that big of a deal. Let's see here. Oh yeah, distributed, of course. We talked about that. We got a global presence. Also offers compliance for like GDPR, especially DataStax Enterprise is that'll do like encryption at rest. And I think our AstroDB just achieved like SOC 2 compliance. So we're working through all that. So it works really great. I've used it a lot in the retail sector for sure. Oh, and then cloud native, of course. The cool thing about Cassandra and a lot of other tech that's similar to it is that it works great in the cloud. A lot of things you have to they require a lot of engineering to work seamlessly in the cloud. A lot of distributed databases will have things like instances or nodes of special roles. So you'll have like a primary node, maybe you have like an ingest node, maybe you have like an indexing node, and sometimes with those special roles, it's difficult to adapt that for like a seamless cloud experience. But, again, the way that the Cassandra type databases work is that each node is a peer. They all kind of do these little things, and, makes it a lot easier. And again, that makes it great for, APIs and data layers. So right now, if you were to use open source Cassandra, and let's just say you're building a quick Java app and you're using one of the drivers, that will actually make like a CQL connection to one or more nodes. The trick with Stargate is that Stargate sits in front of those Cassandra nodes or in front of the cluster, and it's load balanced. So, you can go ahead and have a few of these Stargate nodes, just depending on, like how much throughput you're anticipating here. And it'll go ahead and, aggregate a lot of those connections for you. All right. Okay, I blew through that.
Quick question.
Sure.
So in the previous slide, you're talking about Stargate sitting in front of Cassandra, right? Mm-hmm. And if you're using CQL, mm-hmm. Cassandra by design, right? It's very highly available, eventual consistency and everything is provided by Cassandra by design. Mm-hmm. So what's the benefit of Stargate then if I'm using a native CQL?
If you're using native CQL, you're right in that. If it were me, you're right. I would probably just go direct to the cluster. Yeah, you know.
Stargate adds value for an instance. Like, is it connecting to Cassandra using native protocols or using HTTP?
It is connecting using native protocols. Yeah, yeah. So that part is solid. And you don't have to worry about it, and yeah.
Okay, so it does not have to worry about all the network connectivity around using HTTP.
No, no. Yeah, and that's kind of the good thing too, in that it'll do a lot of that network discoverability. You know, with Cassandra, each node, you know, through that gossiping protocol, has an idea of the state of a lot of the other nodes, and it's able to talk through a lot of that too. Does anyone know how we're doing on time, real quick? And when does the next session start? Yeah. Oh, you know what? We might be actually out of time. I have the schedule on my phone. Let's look at what we got here quick. At least I thought I did. There we go. Oh, 11. Oh, that's right. We're good until 11:35. Or yeah. So we got time. We got time. Okay. Sorry, I apologize for the lack of organization here. Anyway, so we'll real quick walk through you know, how to get going on Astra, which is our software as a service platform. The cool thing about Astra is A, it's free, and B, Stargate is built right into it. Okay. Excellent. All right. You know, let's just burn through right to this. So here is our Git repo where I have kind of all this laid out, and then the sign up for, you know, getting an Astra account and getting access to a lot of the software we're talking about here is excuse me, right below there too. All right. So let's spin through this. Let's see here. Right, I have to come on and let's escape that. Okay. All right. So the first thing that we're going to do here is to go ahead. Yeah, here we go. All right. So let me do that. And we'll jump out to Astra. I already have an account out here. So I'll just go ahead and quick authenticate with Google. All right. Notice it says right in the middle, current plan free. What I'm going to do is, there we go. I'm going to create a key space. And really, you know, for the Cassandra compatibles, a key space is really just an analog to what you'd have as like a logical database. So I will go ahead and jump back to here and say, all right, we'll use, actually, let's go back. Do I have any of these? Oh, no, they're all hibernated. Okay, let me do a resume here. And then I'll jump into our workshops, okay? And I'll say, oh, yeah. Let's get a chance to refresh here. Come on. Sometimes doing a resume takes a second here. Oh, come on. It says we're online. All right. And Mike, right?
Yes.
Yeah. Okay. All right. This is taking a little longer than it should. I suppose that's the perils of doing a live demo, huh? Yeah. Okay, there we go. It's back. All right, so we're going to go ahead and just add a key space called KS1. You know, nice and simple. I will say that for production circumstances, do not name your key spaces KS1. All right, so now that we have one of those, let me jump back to here. Okay, so now we can go to our CQL console. And actually, this is you know, a little bit of the CQL language here, just to put some structure in. I'll go ahead and click that icon to copy it. And then we'll run to CQL console, this little tab right up here. Oh, come on. Hey, there we go. All right. Let me zoom in, because if you're like me, you need to see things in a little bigger font. All right, so let's go ahead and paste that in. There we go. So now we can describe our key space. Actually, you know, let me. Oh, I can't make that smaller, really. All right. So you can see we have our tables out here. We have one table called videos, and then we have a type in there as well, which is a special way of kind of persisting your data inside of Cassandra. All right. Then if I jump back, we can go ahead and make sure we have some data out there. So again, the cool thing is in this README to follow along the examples. All you really have to do is just click this icon, and you'll get a little note that says "copied." Makes it nice and quick. All right.
Initially, Cassandra had a lot of limitations. I'm not sure if they've overcome that in the last couple of years or not. They had a lot of, if my primary key is not part of my key space, searching was a really embarrassing.
Right.
That was the
Right.
rationale that I was evaluating in the past. My team was evaluating which NoSQL database to use. That's where we want to Cassandra realize we design a query first and then data model.
Right.
Is that the same thing?
That is still the case. Yeah. Yeah. Astra does have some ways of doing like we call them like storage attached secondary indexes that do work better than they do in stock Cassandra. But yeah, thinking about your queries first, the questions you're going to ask it is really the main idea when you're putting a lot of this together. Yeah. That's a good call out. It is because that's one of the things you need to think about with Cassandra for sure. Yeah. All right. So we have that out there. So kind of also cool is that CQL allows you to use like a JSON keyword as well. So you can insert things that are actually JSON just by let's see, where was it? Oh yeah, just by adding JSON there, and then you can put the the JSON structure along with that as well. So now that we've got all that, let's have a look at our REST API. So the way that we're going to get to this is by jumping over back to Astra, and we'll go connect, and over here in the left nav, I'll say REST API, and what it's going to do is give you a REST API that's specific to your account, your instance. And the cool thing is it's going to have your access token already in here. So you don't need to worry about generating a token, adding it in. So that'll bring you to the, the Swagger spec here. And then you can go and, let me spin back to, oh, yeah, okay. So remember that it's versioned, so that if we look at the schema section, here we go. And we can go ahead and do we can have a look at all. Oh, that's V1. Yeah, see, I already did it. We want to make sure we're using V2. So let's, we can have a look at all of our tables. I can say try it out. Again, you can see that my token is already inserted in there for me. And I do need to specify a key space. So remember our terrible key space name of KS1. And then I can just hit execute. And for rest, you can see that it came back with, oh, hey, there's our videos table. That's a part of our key space. So now, let's see, I did that. Oh, yeah, we can look at types as well. I mentioned that we, before did create a custom type. So if I go and collapse this, of course, the drawback is I'm looking at a much smaller version of what you're all seeing up there. Oh, let's see. U2 key spaces. Oh, hey, here we go. Get all types. So again, in this, I can go ahead and say, hey, try it out. We've got our key space name of KS1, and I can hit execute on that. And you can see that we have our type in here of video format. So that all does come back. Let's see here. Oh, that we can also create a new table through this as well. And again, this is just by sending a HTTP post through the REST API. Oh, and I forgot that we have our handy copy button there. All right, and the endpoint I want is that, key spaces, tables, and create. So there we go, create a table, just like that. And again, try it out. Inside of this, I'll just go ahead and do a paste of everything that we just grabbed, and I can run an execute on that. Oh, I forgot to add a key space. See, the good thing is that this will stop you from doing it wrong to some extent. There we go. And that's in there now. All right. Let's see.
All the error handling and everything is built into this. So, for example, if I give a wrong key space name, what will happen?
If you give a wrong key space name, yeah, it'll come back with a 400, I believe. So it'll work if you're working with REST. It'll work off of the standard HTTP codes. Okay. Yeah. But the cool thing too is that I can go ahead and insert records using this. So that's going to be the add row endpoint. And that is, oh, right, that's going to be in data. And I want to make sure we're using the V2 of that. Remember, there's that whole bit about using versioning in your APIs. That's very important. All right, so we're going to go KS1, and the table we created was users. And I'll just go ahead and paste our JSON in there. All right. So, yep, came back with a 201. So we're good. We've got that record in there. And I can add a couple other records here. Maybe I'll just put one more in the interest of time. All right, so let me do that, and we can go and execute. And there's the record for David. And then let's see. Oh yeah, we can go ahead and return all rows. So let's close that and get rows, retrieve all rows. There we go. And we can say try it now. And we're going to have key space of KS1. We're going to have our table of users. And I don't need to add anything else. I can say execute, and we should have Cedric and David. Haha. Outstanding. All right. And we can also read a single record or partition as well. If you go ahead and you give it a primary key, you can delete a row. Let's see here. If we use the document API, what we can do is then we start working with things instead of key spaces. the syntax changes a little bit to what we call namespaces. And for that matter, it's like, you're working with namespaces and collections of documents in that sense. But really, it's just an abstraction that you can see underneath. So if I scroll to, let's see here, where's documents? There we go. So I can have a list of namespaces. Oh, that lists the collections in a namespace. Well, let's see here. Let's go KS1 as our namespace. Oh, and that's empty. Okay, so we haven't added anything in there yet. All right, so hey, let's go ahead and create a document. So I'll grab this particular document right here, and we'll use the post namespace. So that's going to be KS1 and call1. All right, let me collapse that and create new document. Here we go. So let's try that out. And we'll say KS1 and collection1. And now, if we paste that in, well, it's thinking. Hey, there we go. So it created it. We didn't have that collection predefined, so it went ahead and created that on the right, which is good. And it gave us back a document ID, which of course is the unique identifier for the document that we just inserted. So let me grab that. And then if I scroll back up to here, we should be able to get, let's see here. It's like get namespaces collection. All right, I'm gonna have to go look, but I know it's the next example here. Yeah, retrieve documents, there we go. Oh, okay. So getting a document, right. Namespace, yep, okay. Collection ID, and somewhere around here we go, we have document ID. Outstanding. All right, so we can say, try it out to start with. Say KS1 and COL1, and we'll do a document ID that we just copied there. And with any luck, this should show the record that we just put in. Hey, outstanding. Outstanding. All right. Oh, yeah, it helps if I have focus where I need to have focus. So let's skip around here a little bit. Let's go ahead and create a new key space, and then I'll do a quick demo of the GraphQL interface just to show you all how that works too. So we're going to create a new key space called library. So let's go back to my workshop database, and let's say new key space library, and we'll save that. All right. Then we're going to go back up here to connect. You remember before we went down and clicked on the REST API. Well, now we'll click on GraphQL API, and this will launch what we call the GraphQL playground. And again, you have your own unique identifier that lets you run GraphQL against your database. And important to note, there are two tabs up there. There's one that's for schema, and there's another one that's just for GraphQL for pulling data. And you want to remember that when you're creating things, to run them on the schema tab, and pulling things back and actually manipulating the data you want to do from the other one. But I can run through. Actually, I shouldn't need this anymore. But we'll just do two quick examples here, and then we'll get going as time's winding down. Yeah, here we go. So if I have a mutation, I can say use this query, and we'll copy that. And let's go to our GraphQL playground, and I'll paste that. Okay, no problem. All right, so if I put that on the schema side, I should be able to run this. Oh, again, that helps if I'm at proper focus. Hey, look at that, it made it in there, outstanding. Okay, yep, okay, that's expected output. Let's go ahead and put something out in the table. Now, you'll notice too that it says that we have to change the GraphQL tab to make this work. So let's grab that. Back to the playground. We're going to switch tabs here, and real quick, I'm going to get rid of that system label there, right? And we'll say library. All right, and then let's paste that in there, and then hopefully this will work. Oh, and it doesn't like something. Let me get rid of that. All right, so my rate of showing things that work flawlessly in a demo has failed. But with time winding down, essentially this is just a quick intro into what we offer through as the ways to work with your data through Stargate. Showed a little of REST, showed a little of Document API. Got as much to work through GraphQL as I could given the time. But just, hey, thanks everyone for coming out. And remember, just for being here, you get entered into our drawing for a gift card. So there you go. All right. Well, hey, barring any questions, thank you all so much for coming. It was great to see everyone.